Okay, so I left off early in here because the camera cut out, but um, so explaining more of this equation. So we figured out the rectangles. So now I want to explain what each of these pieces kind of are in this equation here. So first thing to find is delta x. Delta x is made up of b minus a over n. And so that's taking our end point and our start point, and then we're dividing it up into how many rectangles, an n number of rectangles, right? So, and when as n gets to infinity, this number will become that infinite amount then. X of I is going to be made out of a plus delta x times I. So the a is just marking the start of the equation, and then delta x is the width of the rectangle, and then I is our counter as we move up. So that way each time we're moving to the next rectangle with the I and the delta x. And then the third thing to do is kind of excuse me, I'm tripping over my words here, is substitute x of I. So x of I will become, if a is 0, then it'd be 0 plus delta x times I. Well, this delta x is going to get a number, and that number may be something like 2 over n or something like that. And so it's 2 over n the number. And so then when you have this number, you're able to put in how far you're going, maybe it's infinity, and plug that number in. And then as you work through the problem, or if you want 10 rectangles, you can work through the problem like we have with the other sigmas and work it out. That might be confusing. I'll give a couple examples. Hopefully that makes sense. Okay, I know this is all botched together, but number 3 is not that. Even though you do want to do that, number 3 is when you take the integral from a to b of f of x of I dx, that is going to be this equation, the limit as n approaches infinity, the sum n I equals 1 of f of x of I times. Okay, here's the reclass equation. I keep running out of space on my phone. But this thing and this thing are the same thing, and this is the process you would use to fill out this equation to get the answer to this integral problem. I'm going to do a problem, hopefully it makes things slightly clearer.